Okay, so here we're going to talk about center of mass. We mentioned it a couple times previously, but here we're going to focus in on this concept. Okay, so as you can see here, center of mass is defined as the point on an object at which its weight appears to act. So basically, an object has a mass, and as a result of its mass, it is pulled downwards by gravity, and that is called weight. The force of gravity pulling on the object's mass is called the weight. Now, the mass of an object may not be evenly distributed throughout the object. Like, for example, your body, your head weighs kind of a lot, your arms and legs each kind of weigh a lot. So, but, other parts of you don't maybe weigh as much. So, your center of mass is kind of going to be dependent on how much each of the parts of your body weigh. If you happen to have a really heavy upper body, maybe you're a big bodybuilder and you've got huge biceps and muscles and neck muscles, and you've probably seen pictures of that kind of thing, but maybe you focus on your upper body and you don't do as much with your legs. Well, then your center of mass is going to be higher up. Whereas if you are an athlete who mostly uses their legs, like perhaps a distance runner or a sprinter or something like that, then you're going to probably have a center of mass that's lower because you have more muscle down there in your legs. So more of your mass is going to be down toward the bottom of you. You will have a lower center of mass. So the center of mass is basically the average position of all of the mass in the object. All right, and then another way of saying that is that if you were to put this object on a beam, then the center of mass would be the point where you could add a support, some kind of thing that would support the object in order to balance it, all right, or make it be in equilibrium. An example would be this guy here. He is a toy, a balancing toy, and his center of mass would have to be above that stand there. All right, so this is a stand. He's designed in such a way that the tip of his foot there is a point that allows him to be balanced. That's not necessarily where his center of mass is. It might be above there. Or it might even, actually, weirdly enough, his center of mass might be below that. But at the very least, the center of mass must be somewhere along that line. All right, as we see right here, the center of mass has to be somewhere along a line that lines up with this post of that support. Okay, so for this balancing toy, the center of mass has to be located on that red dotted line. All right, in general, how can we find the center of mass of an object? Well, that's our question for the rest of this video. Okay, so let's say we have an irregularly shaped object, and let's just say, for the sake of example here, that we have holes in the object and that these holes could be used for hanging the object. Okay, so here we've got an object. It's the same object here and the same object there. Okay, it's just this weird shaped piece of thing, and it's got two holes in it. All right, one hole here and then another hole there. Okay, so we can hang the object from those holes then. All right, we'll just have a rope suspended from a anchor point, and then we'll just hook the rope through that hole and we'll let the object hang. We're going to let it hang until it's stable, and then what we would need to do is basically draw a line on the object somehow. A straight line down from that hole. The center of mass must be somewhere on that dotted line. Okay? It's basically just a property. If the thing is hanging, all right, if it's being supported by this anchor point and this rope, all right, then its force of weight must be acting downward in line, all right, in line with that hole there. All right, otherwise it would be still turning and twisting. So once it's in equilibrium, the force of weight has to be counterbalanced by the force applied upwards by this anchor point, and that means that the two have to be in line with each other. Okay, so then what do? We move over to the second hole. So this is with hole number one. Right, sorry about that. This is with hole number one. Okay, so then we need to move over to the other hole, hole number two. So we're going to flip the thing over, hang it from the other hole repeat the process, draw a straight line down from there, because the force of weight, of course, has to act that way. All right? So, what does that mean for us? Well, now we've got two lines. We know the center of mass in situation number 2 has to be somewhere on this line. Situation number 1, we still have the line drawn on there. So, ta-da! We have an intersection point. So the point where those two lines intersect, right there, that X marks the spot. All right, X marks the spot. That has to be the center of mass. All right, bam, just like that. Okay, so that spot where the two lines intersect, that is the center of mass of the object, provided that we've done our work properly. All right, and then method number 2 for finding the center of mass is if you have a regular shaped object. The previous method was an irregular object. This one is regular, so something that is uniform and has a uniform shape. So an example would be a circular object that is uniform all throughout. Then the center of mass is, bam, right at the center of the circle. You can find that using some rules of geometry, okay? And then, or basically you just draw a radius, as long as, drawing a radius assumes that you know where the center of mass is, though. So basically, you would use some rules of geometry and you could find that center of the circle, essentially. Okay, now, we've got here perhaps a rectangle. Then you could just find the center of the rectangle. If it's basically a perfect rectangle and it's a uniform object, then the center of mass is just going to be at the center of the rectangle. And you can find that by measuring half the length of this side, marking that, half the length there, bam, for example, and then measure half the length of the other side, mark that, and then where those two intersect would be the center of mass. Right? Okay, that pretty much sums up center of mass. Let's get rid of these little drawings here. Well, there we go. All right, so that's the main thing for this video, and I hope that was helpful. And there you go. We'll be doing stuff. Oftentimes there's a question on the test that will require you to understand center of mass, so obviously that's why we cover it. It's part of the syllabus. And it's an important concept just for you to know how it works. Alrighty.